Decay, again, going down instead of going up. Let's take a look and show you what it looks like. Here is the formula for an exponential function. Y equals a times b to the x. You need to know the function. You need to know what it looks like. A is going to be what they call the initial amount. Guys, what does initial mean? It's what you start with. Thank you. Perfect. Exactly. That's what it is. It is what you start with. Guys, if you're dealing with a loan or an item or when you pay for something, whatever it costs to begin with or whatever it's worth, you can go, I can talk over it. Whatever that is, that's the initial amount. That's the A. This is also called principal. If you're dealing with a loan, principal. It's what you start with on a loan. Like if you pay for a house, your loan value is your principal amount. It's what you start by taking the loan out for. Okay, B is going to be what we call the decay factor. Decay factor. It's how much it goes down, guys, every time. Okay? How much does it go down every time? And the decay factor is always found, and this is where some people get lost, so pay attention, guys. It's 1 minus the rate of decay. 1 minus the rate of decay. Guys, the reason it's 1 is because when you pay for an item, you pay for all of an item. You pay for 100% of it. 100% as a number is 1. This is just 100% minus whatever discount. Let's say you got a discount of 20%. Okay, that means you'd actually be dealing with a rate of decay, a decay factor of 80%. Okay. You would be getting it at 80% of the original item. It's just 1 minus whatever that is. 1 is just 100%, guys. Don't make that harder than it is. So the first thing you got to do is go through identify A and B in each one of these. That's all you're doing is telling me what's A equal to, what's B equal to, every single time. I want you to look at every single one of these problems. Every single one of them is a decay problem. Why is it decay? Because look at these numbers. 0.45, 0.01, 0.9, and 3/4 are all less than what? 1. They're all less than 1. If they are less than 1, then it is going to be decay. It's making it smaller. Okay? Because of that, when we go through and identify these, it's really easy. Guys, whatever's in front, that's your initial amount. That's A. 26. Boom. That's it. You're done. The next thing you got to do is the growth function or the decay function. Just give whichever one it is. Okay? So in this case, it's going to be 0.45. That's all you do. On the next one, the original amount is 8. The growth factor is 0.9. It's called growth factor, decay factor. You have to decide whether it's growth or decay. In this case, it's decay because it's 0.9. The next one, the initial amount is 4,000. The decay factor is 0.01. It's going to decay very slowly. Okay, for the next one, it's 260 is that initial amount, and its decay factor is going to be 3/4. Yes, you can have a fraction. Don't panic. Fractions are okay too. Okay, the second thing you're going to have to do is apply this information to actual word problems where you have to actually pull out the information and set up the problem. It is the exact same thing as this, but you're going to actually follow through and work out the math. The math is not that complicated, guys. Don't make it complicated. Here we go. Your calculator does it all. So from here, identify the initial amount A and the decay factor B. First thing you got to do. So start by reading the problem. The number of students enrolled in college is 12,000. That's what you're starting with. That is the initial amount. 12,000. It decreases. It decreases. Don't know where that came from. Decreases. That's a typo. It decreases at 5% a year. Guys, it goes down by 5% a year. So if it starts at 1 and it subtracts that 5%, it always starts at 1 because that's 100%, guys. 1. It's like 100% minus 5%, which is going to be 95%. And what's 95% as a decimal? Guys, you got to be able to tell me this. 0.95. That is going to be your decay factor, 0.95. So when you set up the equation, every single time you're going to be setting it up. Y equals. The initial amount goes first. The A goes first. Guys, you already wrote what A is. It's 12,000 times your rate of change. This growth factor or decay factor, in this case it's decay because it's less than 1, is going to be 0.95. What we still don't know is what to put as an exponent. Your exponent is your time, guys. How long are we talking about? 10 years. And since it's 10 years, you put it to the power of 10. So grab your calculators. Type in 12,000 times 0.95. Power button 10 equals. Now, these are people, so we're not going to have any decimals, so we're going to round to the next whole number no matter what it is. So let's try typing it one more time, make sure you got it. 12,000 times 0.95, power button 10 equals. What's that give you? 7,185. 84? Or 85. You think it's 85? Has it got 4 with something after it? Yeah, so it's got to be 85 because you can't have part of a person, so we always round up no matter what when you're dealing with that. Excuse me. So it's going to be 7185 and it's going to be students. So guys, this is why your enrollment in a college, when they talk about enrollment in a college and they have to be very careful about their enrollment going down, look how far down it went just in 10 years, decreasing at 5% a year. That doesn't seem like that much, but that is a drastic cut. If they lose 5% of their students every year, that's going to cut into their numbers drastically. They'd have to fire staff, they'd have to fire professors, they'd have to do a lot of changes. They'd have to pay for the buildings even though their people aren't there. I mean, it's a big deal to decrease that much. Doesn't sound like much, but it's a lot. Okay, here we go. A population of 100, I hate snakes. A population of 100 snakes decreases, yay, at an annual rate of 18%. How many snakes will be there in 5 years? So A equals, what are we starting with? B is going to be equal to 1 minus what? 18%, which is 100% minus 18%, which is going to be 82%, which as a decimal is 0.82. Alright, 0.82 is going to be your decay factor. So when you set up this problem, it's going to be y equals. Say, what would come first? Times what is your decay factor? 0.82. And how long? 5 years. 5 would be your exponent because we've got 5 years of this. Good thing, snakes going. I know they're good for stuff. I just don't like them. My daughter loves them. I hate them. Grab your calculators. Okay, here we go. 100 times 0.82 power button 5 equals. 100 times 0.82 power button 5 equals. How many snakes we got left? It's 37. What's it on the calculator? So no matter what, if you have part of one, then you got to round up to the next one. So even if it's 0 after, doesn't matter, it's got a number after the 0, right? So it would have to round up to 38. Okay. Anything else before we go on to talking about whether it's growth or decay? You've got to be able to identify this. This is a big thing on your test, guys. This next part, making sure that you know whether it's growth or decay. Okay, here we go. So for this next one, state whether the equation represents exponential growth or decay. Guys, you're not looking at the first number. The first number doesn't matter. The only number that matters is the one with the exponent on it. So we're trying to decide if this is greater than or less than 1. If it is exponential growth, it will be greater than 1. If it is exponential decay, it will be less than 1. Guys, if you're multiplying by something greater than 1, you're making it bigger. If you're multiplying something less than 1, you're making it smaller. So, when you write this, every single time you write exponential, and then you just decide whether it is going to be growth or decay. Bless you, I think. Okay, so example 7, it's 0.92. Is it exponential growth or decay? Decay is correct. It is less than 1, so it is going to be decay. Number 8, example 8, it's 1.03. Growth or decay? Growth. Okay, this one is 3. Growth or decay? That's really growth. That's 300%. That would get very big very fast. And then 0.04. Decay. It actually would get small very quickly. Okay, questions, concerns, anything about that set of notes? Good. Alright. So, today's assignment is going to be PWS 7-7B. I'm going to go ahead and pass this out to you. Get started as soon as you get it. And let me know what you have questions about. Thank you. These go quick, guys. Everything is okay. Oh, I don't know about sheets in there, but the notes are all online for you to find. But I'll look and see about the sheets in a minute. That's what I'm doing right now, is trying to get everything fixed that the subs did not fix. That's the nicest way to put it. That's okay. I didn't check it. That one, I didn't even look. Right up. That stuff from the sub? No. No, so you're good. Just make sure it's in folder for folder check. But thank you for letting me know. You're good. Lord, that was the chaos that I came back to. Y'all understand. Y'all, subs are lovely.
They were actually not that bad.
No, they were not compared to thumbs. But this, keeping things organized.
Or a little bit with some of the older students and maybe
If you have a question, come on up, sweetie. Come on up, guys, if you have a question. I'm just trying to get this filled in. Certainly answer questions. I'm just doing the check. Actually, yes, because you can't tell because that number is unknown. So you don't know if it's growth or decay. That would be, yes. Yep. 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 Guys, that's a very good question, and I think it's coming up to a bunch of y'all, so let's listen. If you have an exponential growth or decay factor that you don't know, meaning it's x, can you decide if it's growth or decay? So it'd be what? Neither, neither. If it goes up, then it'd be what? Yeah. And if it goes down, it'd be what? Okay. And if it does both, then it's going to be. Does that make sense? Good. Okay. Fix this thing. Lord, mercy. Me, or just that? What you mean? Okay, so it's just like anything else. One shows growth, one shows decay, one shows neither. So does that go up or down? This is going to be going up and down, because one goes down, one goes up. So this would actually go under what category? Yep. Okay, so you would be starting here, you'd go down, and then you'd have to go back up. So if you do both, then it's neither. No, you always start on the left and go to the right, just like you read a sentence. So you would start over here and go over here. So that one would be what? Yeah, and this one would go from left to right, so it'd be, yeah. This one actually does growth in decay, does both. So it's going here, goes down on this side, goes up on this side. So that one's what? Yep.
That one's neither.
Both ways.
I don't know if I really need to.
Okay, guys, listen up. Graphs read just like anything else, like a sentence from left to right. That's two people that have had that question. I assume that's something you're still going to have an issue with. You've got to learn that when you read a graph, you start on the left side and you go to the right. Okay? So if it goes up to the right, then it's going to be growth. If it goes down to the right, it's going to be decay. And then, yeah. And the ones that are weird are neither. Nope, not minus 4. So you got to do that 1.4%, that turning it into that percentage. So you got a 4%. Is it a decrease or a gain? Decrease, so it'd be like 100% minus 4%. So it'd be times 0.96 to whatever, how many years. Yep. Just checking. What is all this stuff? Goes down. Start on the left, go to the right, goes downhill. Oh yeah, guys, do not put just decay. That is a very good point. There is a different type of decay, so you have to say that it is exponential growth or exponential decay. Please make sure you write that on there very carefully. Which one? That's not correct. I got that wrong. Thank you. That's probably just me writing it wrong because I wrote it quickly this morning. Thank you for saying something. Well, there's one more sheet. Let's see when this one was. AWS 7-4. Which one is it? Mm-hmm. Oh wait, you can't write that like that. You gotta write it as 2.5 million is 2, 555,500. That's why you're not getting the right answer. Is that better? Yeah. Even though they say 2.5 million, write it as 2, 5, and then 1, 2, 3, 4, 5 zeros. Yeah, that's why it's not working. Okay, this is 7. I will get this fixed, guys. It'll take me a little while, but I'll get this thing fixed. Okay. Can you show me anything? There's one of yours. Here's number 13. Yeah, no, 1 second, let me just a second. Oh, it's 2 people. 2, 500, 000. Should be 5 zeros after it. I got the 1. Didn't do the 1 minus.
Also, it's basically 2,500,000.
Huh?
It's basically 2,500,000.
Yes, it is exactly 2,500,000. Okay, so this is Haley, which notes did you need? Bartlett? Found 11. Here's 11 for you. I haven't found 10 yet. I'm working on it. like a freaking jigsaw puzzle.
With money, you don't have to earn. I don't understand these ones.
What?
Am I solving it or
Hmm?
am I solving it?
Let's see, write a function of the growth rate. Yes. So, work it out. You have to do the exact same thing you're doing there. Yep. Okay. 60. Okay.